Hello, in this video we will show how to convert this deterministic finite automaton to a regular expression. For this, recall that we have two steps. Step 1 is to convert this DFA into a generalized non-deterministic finite automaton, and the step 2 consists of ripping out the inner states of the GNFA. To start step 1, we will add a start state named here start and an end state named here end. Note that all the old accept state B and T will go to the new end state with epsilon transitions, and B and T will no longer be accept state. Next, we will add the missing arcs out of start. Start will now have arcs to all the different states of the GNFA. The added edges will be labeled by the empty set regular expression. Now we will add the missing arcs out of A. As you may see here, the edges going out of A are this one going to B and this one going to C. So we will need to add an edge to itself and another edge to the state end. And these two edges will be labeled by empty set. Now for B, there's one edge which is missing, this one from B to A. So we will add it and we will label it by the empty set regular expression. For C, it has one arc going to it and one edge going to end. We will add two edges, one going to B and one going to the state A, with empty set on these two edges. And now we have the GNFA completed. Let's move to step 2, in which we will remove A, then B, then C. For state A, we will remove it and remove all the edges going out of it or going into it. And we will have to replace all the regular expressions on the remained arcs. Okay, let's see here for transition from start to B, we will write empty set, the original regular expression, and we will write via the operator union the possible way if we're going from start to B through the state A. Okay, in this case we have epsilon, then empty set star, because we may pass through this edge 0 or more times, and then 0. And we will write down this regular expression here and we will simplify it. We will find here 0 because epsilon concatenated to epsilon, empty star is also epsilon, concatenated to 0 is 0, and 0 union empty set will result into 0. Okay, now for the transition going from start to C, we will write here from start to C empty set here, or the way if we take start then A then C. Okay, in this case we'll have epsilon empty set star 1, and this regular expression will be simplified to 1. Now let's take the transition between start and end. We will have two possible ways. The direct one, in which we have the empty set regular expression, and the way if we pass through A. Through A we will have epsilon, then empty set star, then empty set. And in this case, empty set concatenated to anything will be empty set, and the result here will be empty set. For B, we can go to B itself via 0, or we can go to A and come back to B again. In this case, we will have empty set star, and 0. Okay, and the result here will be just 0. For the transition going from B to C, we will write down here 1, or via A, we will have empty set star 1, and the result will be 1. For the transition going to AND from B, we will write down here epsilon, the direct way, or the one through A, it will be empty set star, empty set, and the overall result here will be epsilon. Finally, for C, also we will change all the arcs going out of C, okay, and we will have from C to C this one, or we will go to A with empty set, stay here with empty set star, and go back to C via this one, and the result here will be 1. Now for the transition from C to AND, we will write epsilon, since it's the regular expression on the direct link between C and AND. And the second one will be empty set to A, empty set star on A, and empty set to AND. We will write down here empty set star, empty set, and the overall result when we make the union with epsilon will be epsilon. The last edge to change here is the one linking C to B. Here we will write empty set because it's on the direct link between C and B, or the regular expression on the way from C to A then to B. This one is empty set star 0. And here the overall simplification will lead to empty set. We cleaned the last diagram here after removing the state A, and now we'll focus on the state B and remove it. The machine to the right is the one without the state B, and on which all the remaining transitions were modified. From start to C, we will write down 1, union, the way from start to B then to C, which is 0, 0 star 1. And we have no simplification here. For start to end, we will write empty set here, or the way through B, which is 0, 0 star epsilon. And the result here will be simplified to 0, 0 star. From C, also we have 2 ongoing arcs. From C to C, we will write 1 here, union, empty set to B, 0 star, and 1. And the overall result will be simplified to 1. The last edge is the one from C to AND, and we will write down here epsilon, or empty set 0 star epsilon, and this will be simplified to epsilon. Let's clean out this diagram. We'll obtain the automaton to the left. Now we have to remove the state C and all the arcs related to it. The result is shown on the automaton to the right, where we'll have a transition from start to end with the regular expression that is in fact the union between 0, 0 star and 1 or 0 0 star 1 concatenated to 1 star concatenated to epsilon. And this may be simplified to the following regular expression. We may optimize, we may write here, for example, the union followed by the concatenation as the union of two regular expressions, which are 1 1 star union 0 0 star 1 and 1 star. Also, we may write each 0 0 star as a 0 plus, since plus means one or many occurrences of 0, which is the same thing as 0 concatenated to 0 or more occurrences of the symbol 0. Also, 1 1 star may be written as 1 plus, and 0 0 star in the second part as 0 plus, 1 1 star in the last part as 1 plus. Also, we can optimize this with the following. We may write 0 plus, or in the second part here, it's always 1 plus, which is preceded by 0 plus or no. So we may write here 0 plus between parentheses question mark, which means that the 0 plus here is optional, and it will be followed by 1 plus. Another possible optimization is to write 0 plus followed by an optional part, which is 1 plus. As we may see here, we have the possibility to write 0 plus alone, or 0 plus 1 plus. And the last part, 1 plus, which is written from here. Now we have completed the conversion from this deterministic finite automaton to its corresponding regular expression, which is 0 plus, optional part 1 plus, union 1 plus. That's it for this video. Thanks a lot.